Have you ever wondered what's inside a black hole? A place where space, time, even reality itself breaks down. Scientists have studied them for decades, yet we still don't fully know what's really hiding inside. Today, we explore one of the most mind-bending mysteries in the universe. The concept of black holes was first predicted by Einstein's theory of general relativity. In 2019, the Event Horizon Telescope captured the first ever image of a black hole. Black holes form when massive stars collapse under their own gravity. They consume everything in their path, even light, making them invisible to the naked eye. Despite their invisibility, scientists use indirect methods to study them. The detection of gravitational waves has opened new avenues for understanding these cosmic enigmas. Black holes play a crucial role in the evolution of galaxies and the universe itself. Join us as we delve into the mysteries inside black holes. A black hole is what's left behind when a massive star dies. Its core collapses under its own immense gravity. All the matter squeezes into an incredibly dense point, a singularity. This collapse forms an invisible boundary, the event horizon. Anything that crosses it can never escape, not even light. Einstein's theory of general relativity predicts this. Mass curves space-time, and a black hole is like a bottomless pit in this cosmic fabric. But how can something so destructive also be so fascinating? There are different types of black holes: stellar, supermassive, intermediate, and primordial. Stellar black holes form from the remnants of massive stars. Supermassive black holes, millions to billions of times the mass of our sun, reside at the centers of galaxies. Intermediate black holes are thought to form in star clusters. Primordial black holes might have formed in the early universe. Despite their differences, all black holes share the same fundamental properties. They warp spacetime, create gravitational waves, and can merge to form even larger black holes. Black holes remain one of the most intriguing and mysterious phenomena in the universe. Let's break it down. At the core is the singularity, a point of infinite density and zero volume. We don't know what it looks like or what laws of physics apply there. Around it lies the event horizon, the point of no return. Cross that line, and escape becomes impossible. Surrounding it is the accretion disk, superheated gas and matter swirling at near light speeds. As this matter spirals in, it heats up and emits X-rays, letting us detect black holes indirectly. Some black holes also emit powerful jets of particles at nearly the speed of light. The immense gravity of a black hole can bend light around it, a phenomenon known as gravitational lensing. Theoretical physicist Stephen Hawking proposed that black holes can emit radiation, now known as Hawking radiation. Over incredibly long timescales, this radiation could cause black holes to lose mass and eventually evaporate. When two black holes merge, they create ripples in spacetime known as gravitational waves. These waves can be detected by observatories on Earth, providing us with more information about these mysterious objects. Black holes are formed when massive stars collapse under their own gravity at the end of their life cycles. Occasionally, a black hole can tear apart a star that ventures too close, an event known as a tidal disruption event. Black holes can also have strong magnetic fields, which can influence the behavior of matter around them. Supermassive black holes found at the centers of galaxies play a crucial role in the formation and evolution of galaxies. So, what if you fell in? First, you'd experience spaghettification. Yes, that's the real term. The black hole's gravity stretches your body like spaghetti. Your feet feel more pull than your head, tearing you apart atom by atom. Time also behaves strangely. To an outside observer, you'd appear frozen at the event horizon. But from your perspective, you'd fall right in, and time would feel normal until it ends. As you approach the singularity, gravitational waves become incredibly intense. Einstein's theory of general relativity suggests space-time warps dramatically. Quantum effects also come into play, potentially leading to Hawking radiation. The information paradox questions whether information is lost or preserved. Over immense timescales, black holes might evaporate through Hawking radiation. In its final moments, the black hole could vanish, leaving behind mysteries yet to be solved. Now the big question, what's inside the singularity? Here, our physics breaks down. General relativity predicts infinite density. But quantum mechanics says, that can't be. This conflict is one of the biggest problems in physics. We need a new theory, quantum gravity, to unify these ideas. Could it be string theory? Loop quantum gravity? We're still searching. Some scientists believe the singularity doesn't even exist. Instead, space-time might bounce back, like a spring, or form a Planck star, a quantum bridge to somewhere else. The singularity is a point where our understanding of physics collapses. Stephen Hawking proposed that black holes could emit radiation, known as Hawking radiation, which might eventually cause them to evaporate. The holographic principle suggests that all the information inside a black hole could be encoded on its surface, leading to the black hole information paradox. Roger Penrose's conformal cyclic cosmology theory posits that the universe could be cyclic, with black holes playing a crucial role in the transition between cycles. At the Planck scale, space-time might be a frothy, turbulent quantum foam, where the classical concepts of space and time cease to exist. Some theories suggest that singularities could be gateways to other parts of the universe, or even to other universes, through wormholes or Einstein-Rosen bridges. The multiverse theory proposes that our universe is just one of many, and black holes could be connections between these parallel universes. The true nature of singularities remains one of the most profound mysteries in science, challenging our understanding of the universe and our place within it. Black holes might be more than cosmic traps. Some theories suggest they're wormholes, shortcuts through space and time. Could you travel to another universe through one? Or perhaps every black hole is a seed for a new universe, a baby universe expanding on the other side. It's mind-blowing, but possible. Others believe reality is a hologram, and everything inside a black hole is encoded on its surface. The information paradox asks, if you drop a book into a black hole, is its information lost forever? Stephen Hawking believed it could be preserved, in the event horizon's quantum ripples. At the heart of a black hole lies the singularity, a point of infinite density. Time itself warps near a black hole, slowing down as you approach the event horizon. Black holes might not last forever. They could slowly evaporate through Hawking radiation. When black holes collide, they send ripples through space-time, known as gravitational waves. Advanced simulations help us understand these cosmic giants better. Some black holes emit powerful jets of energy shooting out into space. As they feed on surrounding matter, black holes grow and evolve. They form when massive stars collapse under their own gravity, often following a supernova explosion. Many galaxies, including our Milky Way, harbor supermassive black holes at their centers. The mysteries of black holes continue to captivate scientists and fuel wild theories. In 2019, scientists captured the first image of a black hole's shadow in galaxy M87. It confirmed Einstein's predictions, again. Today, new telescopes are peering deeper than ever. We're learning how black holes shape galaxies, stars, even life itself, but the mystery inside them, still unsolved. Theoretical physicists have proposed numerous ideas about what happens inside a black hole. Some theories suggest that quantum mechanics could hold the key to understanding black holes. Others speculate that black holes might be gateways to other parts of the universe, or even to other universes. The Event Horizon Telescope team continues to work on capturing more detailed images of black holes. Future space missions and advanced telescopes promise to reveal even more about these enigmatic objects. The quest to understand black holes is ongoing, with each discovery leading to new questions. Computer simulations and models help scientists visualize what might be happening inside black holes. Crossing the event horizon remains a point of no return, where the laws of physics as we know them cease to apply. At the core lies the singularity, a point of infinite density where our understanding of physics breaks down. As we continue to explore, the mysteries of black holes may one day be unraveled, but for now, they remain one of the greatest enigmas of the cosmos. Black holes are nature's greatest riddles. We know they exist, we've measured them, but what lies inside? What secrets do they hold? We may never truly know. The mysteries of black holes continue to baffle and intrigue scientists and enthusiasts alike, yet the journey to find out is just beginning. Every discovery brings us one step closer to understanding the unknown. Stay curious, and keep wondering. The universe is vast, and its secrets are waiting to be uncovered. Thank you for joining us on this journey. Subscribe for more explorations into the wonders of the cosmos.